Hi everyone. Baada ya kuona nini maana ya trigonometry, leo tuangalie the real relationship that happen between the angle and the side of a right angled triangle. Tulivyoangalia kwenye video namba 1, tuliona trigonometry ni study of the relationship between the sides and the angle of the right angled triangle. So here I do have a right angled triangle, a triangle whereby two of its side make a 90 degree, make a right angle. So this triangle is the one we use to start the relationship that is concerning the trigonometry. When you have the angle theta, we label the sides. If this is an angle of consideration, we know that the side that is opposite to this angle is this side. It is opposite to this angle. So this side is known as the opposite side. And for the same angle of consideration, this side BC is the side that lie next to an angle. It is called the adjacent side, lie next to an angle. And the side AC, it is the side that is stretched under the 90 degree to join the two ends. It is stretched to join the two ends between the opposite and the adjacent. It is called the hypotenuse side. Hypotenuse side is the side that is stretched under the 90 degree to join the two ends, this end and this end, the line that join. It is hypotenuse. So what are these relationships? If you have an angle theta, you see that the opposite side and the adjacent side, it is less in magnitude compared to the hypotenuse side. Hypotenuse side is longer than the opposite and than the adjacent. But what mathematicians observe in triangle whose two sides make the 90 degree is that for a specific angle, the ratio of opposite side to hypotenuse side is constant, whatever the size of the triangle. To put this word clear, when you have angle theta equal to 30 degree. So if theta equal to 30, they said the ratio of the opposite side to hypotenuse side is equal to 0.5 or equal to a half. So for the theta kuwa ni sawasawa na 30 means the ratio of opposite side to hypotenuse side is equal to a half or 0.5. So whenever you have a right angled triangles whereby the angle theta is 30, you will have 0.5 when you divide the opposite side to hypotenuse side. This ratio remain constant for whatever the size of the triangle. If the triangle is bigger than the one I draw here, or is small as the one you will draw in your textbook, but if you measure the angle and it became 30, when you measure the length of the opposite and the length of the hypotenuse and you take the ratio of the opposite of hypotenuse, you will have 0.5. So the ratio remain constant for a specific angle for whatever the triangle, whereby if that triangle is big, so you can have a triangle like the bigger the house. If you, here is the fence and your dad planned to build the chicken house, we call it banda la kuku, and he tried to make it use the fence wall, he will have the tree here, ataweka mti hapa na huu ndio ukuta, then litapauliwa kwa maji kumwagika hivi, ili ndio bati. So if the angle ile bati limeweka na ile horizontal mbao au ule mti uliolala horizontal is 30, it means that urefu wa kutoka pale juu mpaka hapa mti ulipokata, hii urefu wa ile dari humu ndani ukigawanya na urefu wa lile paa mpaka kwenye ile junction, if you call it x, you call it y, itakuwa ni 0.5 kama angle iliyowekwa ni 30. So this is a very interesting concept. there is a specific ratio for a specific angle. And this ratio we discuss here, it is only the opposite to hypotenuse, the side that is opposite to an angle and the side that join the two ends to form the triangle, the hypotenuse side. So when we say there is a relationship between the side and angle of a right triangle, this is what we mean. When you have a specific angle, and the same is, or the true is for the other angle. For example, if the angle is 45, there is a specific ratio for the 45 degree, well, for whatever the triangle. If the angle is 35, there is a specific ratio for that 35 angle for whatever the triangle, the size of the triangle. As long as the size of the triangle is, for wherever the triangle is right angled triangle, for a specific angle, there is a constant ratio or the same ratio for the same angle between the opposite and the hypotenuse side. So here I use 30 as an example and say if you have the angle 30, or the ratio of the opposite side to hypotenuse side will be the same. If someone try to have this triangle, for example, here at the center, and you have the triangle in such a way that if this length is y or is x, here is x over 2 and here is x over 2. So if this is y, here you will have y over 2. Means what? For the same angle, if you have the hypotenuse, also the opposite side became half. Why? Because for a specific angle, the ratio of opposite to hypotenuse is constant for whatever the triangle, as long as the triangle is right angled triangle. So if you have angle 30, this also ratio becomes 0.5. The ratio of this one to this one becomes 0.5. Even if you make this triangle large enough, you stretch these two sides so that you make a big triangle, but that triangle is also a right angled triangle. This length became large and this length also became large. What will you have? Still the angle is 30. The ratio of the opposite side to the hypotenuse side will still remain 0.5. So this is one way of explaining the relationship between the side and the angle of the right angled triangle, of which it is the trigonometry, the measurement of the three-sided shape. So here it is just a few concepts I tried to plug on the student brain to see where that the concept of sine and cos came from. But before that, just see that there is a specific ratio for a specific angle between the opposite and the hypotenuse. If the angle is made here, this is opposite side and here is the hypotenuse side, there is a specific angle there is a specific ratio for the specific angle. The ratio of the opposite to hypotenuse is constant for a certain angle for whatever the size of the triangle. I'm sure my words are clear and you get the concept. The same as for the adjacent side and the hypotenuse side. For the same angle, also the ratio of adjacent side to hypotenuse side is constant. So if the ratio is 0.877, will remain the same as adjacent over hypotenuse. If the ratio is 0.877 for the angle 30, this ratio will remain the same for the case of any right angled triangle. As long as the angle is 30, the ratio of the adjacent side to hypotenuse side will be 0.877. If you took this triangle, if you take this large one, or you take the largest one, the same as when you took the adjacent, you divide by the hypotenuse, the ratio will remain constant as long as the angle is the same. So this is a very interesting concept. For the case of our banda la kuku, what will we have? What we'll have is that if you took the adjacent side and you divide to the hypotenuse side for the same angle, the ratio will be constant. If here the angle is 30, we will have 0.877 as an example of the ratio. So this will be the same. This will be the value if the angle is 30 and this adjacent and this is an hypotenuse. You will get this ratio. If you draw that triangle in your textbook, you use the rulers for the measurements and the kipima pembe, you get the angle 30. That triangle will have this ratio for the case of adjacent and hypotenuse if the angle is 30. So this is a very, very earlier concept of the trigonometry before we go any further to other concept. I'm sure till here, even if the ratio of opposite to adjacent is the same for the same angle, the last ratio or the last concept is even if the opposite to adjacent side will have the constant ratio. If the concept is 0.1442 will be 0.1442 for whatever this triangle. If you took this triangle, the ratio of the opposite to adjacent, if you take this triangle, the ratio of the opposite to adjacent, even if you take this one, the ratio of the opposite to adjacent will maintain or will remain the same for the same angle for whatever the size of the triangle. Even this one, the case of the bandala kuku, the ratio of the opposite to adjacent side, if the angle is 30, the value will remain the same. So this is the concept, and it is very useful concept in real life. As long as you grasp this concept and you use this in real life, you can make anything that make the right angle, the triangle, simpler. Since if this is bandala kuku in this shape of right angle triangle, or even if you make the house that the roof is designed in such a way that we do have the high side and the low side, the waterfall toward the front side of the house, you'll make the triangle between the gypsum body and the roof and the wall that the roof meet the wall. You will have this right angled triangle and it will maintain or will follow the rules. So be happy with that, and I'm sure in the next video we'll see where does the sign and the concept, of course, the concept of the tangent came from. But here you see that there is a relationship between the angle and the side of the right angle triangle. Thank you. See you soon.